Can you put this one? I think यहाँ पे हो. So very good afternoon to all of you, and it's my honor to present this basic concept on information hiding before you people. The topic is not so new. I hope many of you must have heard the basic name of information hiding. What we call it is the Steganography in the digital terminology. And this is not a new concept. The sense that as an art, this is being used since time immemorial. As you see this, normally whenever you have to preserve the secrecy, the privacy of any information, you resort to either encrypt that or just sell in some envelope, write it in top confidential, and pass it from the one place to others. So even whenever you are passing, the basic media of communication, what we call it channel, is visible. There is something, some communication is taking place. But here steganography is such an art, and even that very channel of communication is hidden. So for the onlooker, it is completely invisible that some communication is taking place. It's very strange whenever you are listening very first time. But actually it happens, because on the face value, you will find that something else is going, but under the beneath, something else is there. Correct? So one of the typical example, once you read this, the literature on the information hiding and the steganography, you will find that in the old time, the people used to convey the message from the one place to others by using the human being as a what is called channel, the media of communication. And this is the one example. Here person, the shave off initially the head, now on the bald head you write something, put the person in prison for 6 months, let the hair grow over that, and once it is grown, and then let the person move from one place to other. Once the person has reached to the destination, shave off the head again, read the message, possibly erase the message as well, and this one. So whenever the person is traveling from one place to other, it looks like the messenger is going and must be carrying message in the pocket in forms of some letter or something. But in fact it is not. Message is somewhere else. On the head, nobody can suspect even. So that what we call it is the art. But with the advent of the computer technology and the multimedia resources, like the many digital covers, the term I am using before actually defining it, like the file, we call it, the image, audio, video, file which is traveling across the net, and it has some peculiar property. You know the format, you know the programming, you know the bit manipulation. Using that, you can embed the information inside that. So for the onlooker, it will look like only image is passing. You are sharing your photograph between the person, but in fact you are sharing something else. Else means a message hidden inside that one. So where the message is hidden, that is the channel. Channel we call it like the bit place and all these things. That is basically hidden, is not known. The basic communication channel itself is hidden over there. Let's see one interesting example. The diagram I will show you. Suppose this is the image over there, and somewhere some secret message. There will be the hiding algorithm, what we call embedding. This takes the cover and your secret message as the input. Apply this embedding algorithm. This is performed by the sender. This embedded, because the cover is changed. The original cover now we call in this terminology as the Stego cover. Possibly you can use some key as well. It is optional. And once the Stego cover is, it is transmitted on the line through the net, whatever the communication media. So for the person who is seeing, it looks like only the original image. The secret image is not visible because inside that one. At the receiver side, it will be extracted by the extracting algorithm. The secret message has come. Now see the cover. Because the originally cover was distorted. So once the message is extracted from this, you will get the cover, but it is not the original cover. A lot of work is going on. How to hide this in a reversible way. Whenever the message is extracted from the Stego, we should get the original cover as it is. It needs the many work has been done, people are working on that. This is, here in this case, all the time, whenever you are transmitting, don't say, don't assume that it is going on the utopian channel. Nobody is trying to look into that. The just attacker is all the time working on this transmission. And they will be working just to destroy this image itself. If they know something can be hidden in this one, then another message may be hidden on that. I mean, just like the crypt analyst, the Steg analysts are also working all the time over there. Correct? Now, there are the two areas, what we call it, the domain of trust. So, there is no problem at the sender side, no problem at the receiver side, but there is a problem in between. And that is why the sustainability and the strength of the embedding algorithm is judged. Once it is passing in this attacker area of the attack, how secure the Stego cover is going to be. And if something is distorted, then is there any way to recover from that damage? So here, whenever if there is no change, attacker is not successful in distorting this one, then whatever is being transmitted, the same message will get extracted. But if some distortion happen, then something possible, some severe change. Then whatever the secret message, suppose copyright information, but the information received is going to be. Then there is a many code, the E code, T code and so on, the recovery mechanism have been developed. Using that in the contextual, if this the CO and the P is missing, then in the context this message can be recovered. What we call this is the using the T code and something. This is the mechanism over there. Correct? Now, this is the basic concept of the information hiding and the steganography. One example I have taken, that is of the image. Image itself can be of the different type and the format in which it is stored. And every image has its the peculiar characteristics. What we call word, we use it, redundant data. The data, if you remove it from the image, overwrite it with some other information, then the basic characteristic of this image is not going to change. So if you find some redundant data in the data format, you have got the area. you can utilize that area to hide something in that. So all the time the steganography and this information hiding, but how to find those redundant data inside, so that it can be manipulated, it can be just some information can be written into that, correct? Now this, all the time the technique is how to find those covert channel. Covert channel is defined as any communication channel. Communication channel we say is not like always the pipe, VPN and all the wire what we are seeing in the communication line and the network and wire is coming over there. That is not always the communication channel. Even in the image, whatever the byte we are getting, and if we are manipulating something over there, that also uses the channel of writing some data over there, and that entire image we are passing. So that is the covert that can be exploited by a process to transfer information in a manner that violates the very security policy. If it is detected, then it is not information hiding, correct? That means if the technique has violated, there is no way it is hacking, so don't relate with that. There is no way the cyber attack, it is no way it is a hacking, no way it is what is stealing data of somebody. Only thing, it should pass whatever the security policy is there, because it is not aware that some communication is taking place. So that system, it violates the system security policy. There are the two categories of the covert channel. One we call is the storage, another we call is the timing. Storage, like we call it, is the image and all these things, the data format. We are getting this bit, changing it. So one example I will show you, 1-2 example over there, how we are just manipulating that. And the timing channel, we use the modulation and all, I think entire network communication, and by modulating the wave, that also we can use to load, correct na? The information over that, the payload, either this timing or the storage. In the storage, basically we have a cover, digital cover we call. This cover is nothing but a digital file, which can be a document file, which can be a PDF file, which can be an image file, any format, maybe BMP, that JPG file, maybe PNG file, TIFF file, maybe or the audio file in any format, maybe the video file in any format. So, they are the rich resources of the digital cover. Take it, whatever the message you want to embed in that, you take that one. So, that we call it is the covert storage. How we are writing into something, and if we are modulating and putting on some information, then this is called the timing, that is the covert timing channel. We will be discussing the first one, because the second one is related to your all the network communication, the modulation and so on. And normally this is of the 3 time, and the way the care is taken, sometimes suppose you are using the document file, and somewhere instead of using the redundant data, whatever the message you want to convey, you have embedded as it is in some in between. The in between means original text file is suppose of the 1 KB, 1000 character, let us say that, 1000 character, and you are the secret message of the 100 characters. So what you are doing, you are not using any of the 1000 character space, but simply you are inserting this 100 character. I am making the file of the 1100. I hope 1000 character, the cover is there, 100 character your secret message, simply you are putting inside that one somewhere. That means we say that that payload is simply injected inside. The total cover size will become a stego cover size, the cover size plus the message size, which needs to be avoided. So like what we call it the injection steganography. The payload or the embedded data is placed inside the cover. The resultant file is called the stego object in general. Size of the stego object in this case is larger than that of the cover one. But whenever it is there, so there are a number of ways the steg analyst try to recover data or to guess that whether whatever this cover is passing, possibly it contains something. A number of analysis, means side by side, the technique of information hiding is improving. Side by side, the detecting the information from that also is improving over there. All the time, they keep on working over that. So that should be avoided. Means no way you should give this information that the stego is going to be anyway different from the original cover one. The size is one of the factors. Means stego image or the stego cover generated should be size invariant. The size should not change. How to do that? Then the next is the substitution steganography. Instead of injecting there, you find some information. Dono bit hai. Entire computer works in the concept of the bit 0101. If LSB steganography is very popular, find that and they just toggle. Suppose corresponding bit is the 0 of the image and of the text is the 0, you don't have to do anything. If it is the 0 and the 1, simply toggle 0 to 1 using the bit manipulation. So what we call it is the substitution steganography. Just by altering some of the bits in the cover, we just embed data into that. That was the size of the cover is not changing. But what is changing is the some bit location, the bits at the certain location. That is detected. If there are the much change, then it will be visible. But if it is sporadic here and there, then it is not going to be. Even in the statistical analysis, this is not visible. But this gives the 3 parameters which we consider to evaluate the strength of any steganographic algorithm. Correct? The parameter is first the capacity of the cover. What is the maximum size of the message we can embed without drastically changing the characteristic of the cover? So what we call it the capacity. Next is the sustainability. If the message is passing and if somebody is attacking or altering somewhere in the image, so whether the stego will be able to recover, the extraction algorithm will be able to recover the information from that. So what we call the sustainability. And the third one, what we call is the strength. If it is destroyed, how robust it is. Robust. So that is the robustness of the algorithm. Even if whether it is going to be guessed, whether it is going means message will be lost only if the image is completely deleted, the cover is completely deleted. In no other case that image is going to be. So these 3 parameters, evaluation parameter we call it, correct? The next is the propagation. This is the propagation. The here is the very typical one, and the many algorithms have been developed. It does simply we take this cover and the secret message. Then instead of either injecting into that or using that to substitute here, a relationship is found. Correct? How this is the, and this is a very interesting one. How the secret message, which is normally going to be text, and the cover, which is either going to be image or audio, maybe possibly text. No way in the real life they will be related. But on the bit level, find a relationship and try to just pass this relationship itself. Contents of this file also referred as the mimic, and only this relationship will be transmitted. Correct? So there are the 3. But here we will be discussing an approach, the propagation, which is also in the substitution, that is the graph theoretic approach to steganography. And this is a very good emerging area of the research. Particularly, I don't know how many of you have heard the name of Geographic Information System, GIS, National Spatial Database, Spatial Database. These are the areas where a lot of investment is done by the concerned agency to generate the spatial data. And once it is in the digital form, mind it, I am saying the data and the software. So there are many mechanisms has been developed to secure your software against the piracy. You are introducing, and the vendor have introduced the license key. If you have to replicate, then you need a license key to run it. The 1 user license, 2 user license, and so on, so on. Or there is some hardware lock. If you have to run this software, then you need this hardware lock. At a time, it will be running at the only one computer. Okay, no problem, you install on the 10, but it will be running on the only one. But it is very difficult to protect the digital data set. Once you have generated, then how are you going to protect it from illegal copy? And a lot of investment is there. Then how the copying, illegal copying is going to protect the interest of those investors? What is there? How to watermark this very data set itself, so that fingerprinting, watermarking, so that this can work as a deterrent against any illegal copying of the data or the piracy. A lot of work is going on watermarking of the digital data set, and the steganography plays a very good role in that, particularly this graph theoretic approach. Okay. See, what is that graph theoretic approach first, and why it is just being studied in the area of this information hiding, so on. Graph, we all know, being a computer science students, this is nothing but a relationship between some object, spatial. So it is written, a branch of mathematics dealing with the properties of diagram to study the arrangement of objects. In the layman style, we study which nodes are adjacent, what is the degree, in degree, and so on. The adjacency is one of the important factors, which we use actually in the hiding of that. Correct? No? So between the relationship between the object. Theoretic is nothing but an approach. How to use this graph concept or the data structure to solve. This is the approach, is theoretic. It's just the concept or the data structure when we just boil down to the how to use this graph structure basically. Approach means a method or whatever is that, to hide some information in a graph. And not in a graph, but in graphic way. So whenever we use this graph theoretic approach, so there are the two areas. One, hide the information in any digital cover by finding the relationship between the digital cover and that secret matches. Digital cover could be of any type. The only thing is that relationship which we are going to hide. I will show you one very good interesting example over here. Whenever you are going to hide this, we are not hiding basically the information, but the only we are using the relationship among the or between the digital cover and the text image to just convey that this message is already there in the digital cover. Correct? The one is that approach we are using the relationship. Another, use the graph as it is, as a cover, and the hide information into that. But whenever we say the graph, as a student we all know, it is very difficult to find redundant information, enough redundant information in a graph to hide information. Even if we have the 100 node graph, we will get a matrix, adjacency matrix of 100 by 100. There will be a few zeros, few ones over there depending upon the adjacency. And if you alter any 0 or 1, basic characteristic of the graph gets changed. And once it is changing, then anybody will be able to guess this graph is not the original, but this is the changed one. Then how to use, what type of data structure we use for the graph? There is a graph, it is represented as a graph, it is viewed as a graph, but it is stored not as a adjacency matrix or the list, the traditional data structure, but something else, some other way, which gives you the enough redundancy in the representation, and you can use those representations to hide information in that. Correct? So this is the graph theoretic. There are the two ways of using graph for the information hiding. One is the generate graph, that is the relationship and how the graph is generated. And the second one, you use a graph itself as a cover. We will discuss one example for both, correct? But first the basic approach. The very good paper is written by the Hazel and Mutdal, and this is the classic paper treated till today. Now how to use that, and based on that one diagram, and then works on the basic concept, a very layman, a very easy to understand. Whenever you take any digital cover and it is stored on your hard disk, this is nothing but the stream of bits or the stream of bytes, correct? Same way, any text, irrespective of its representation, whether it is the ASCII, the ISCII or whatever is that, it is again the stream of bits or the stream of bytes. Normally, this digital cover, the size is much more. The text, it is going to be, suppose you are going to hide the abstract of a paper, which is hardly of the 100 or the 150 words. The 150 words, it will be 150 into 8, something like the 1200 bits or something like that, if you remove all the white spaces and the punctuation marks and so on, so on. Correct? So this and the image bit stream. Suppose in the image we have the 2000 bytes, for example, correct? And the text is of the 100 bytes. On an average,